My name's John Myatt. I've been involved in a lot of different things over the years. I worked on the Grand Alliance, that dates me. But today we're talking about application deployment tools. And you might say, why would we even be talking about that? Because it's a strange thing to talk about. And how does that relate to television? So, Tina, I'm going to ask you to do Kathy a big favor and take a picture of me sometime. Okay. So, I'm going to stand up just briefly because then it helps me stay awake. So more or less today, I'm going to talk about all these different tools that you kind of hear the names of, Ansible and Terraform and Kubernetes. And how many of you have heard of any of these things? How many of you would consider yourself an expert in any of these things? Okay, good for you. You're hired. I kid you not. That is the first challenge, is that while these aren't like the most complicated things, and these probably are important for the future of all of us and how we do our jobs going forward in television. But these are part of a larger trend in the industry called infrastructure as code. And the idea is that if you've ever stood up or deployed a SMPTE 2110 system or any sort of complicated system, you realize that every piece of the system requires some configuration. It requires you getting all of its settings correct. And those settings are really stuck inside the thing you're configuring. So if you wanted to make a copy of them, or if you wanted to work on them offline and then jam them in, that's kind of hard. And equally, if you wanted to take a copy of all those settings for all the things in your plant, and then like store it up on GitHub just in case the building burned down, that's hard too. But it'd be sure handy if it worked well. And that's what these tools try to do in the context of every industry. There's nothing broadcast specific about these things. So this is sort of an overview talk about what is each of these tools, what does it do, why did it get written, and how they might apply in television. The core idea of infrastructure as code is that you could, in some future universe, write a text thing that describes your target state of your facility. It says, every NMOS sender, every receiver, every device, how it's supposed to be configured. And then you run that little program on some magic thing, and it causes all those devices to actually be set up that way. And that would be really good. And there's a few properties that matter about that. One is that, if it's creating resources, that when it runs, that it has to not accidentally create them over and over again, right? Like every time you run it, it has to have the same results. It can't run and create an extra VM every time it runs or something. If you change the file and maybe you take something out, it should recycle the resources. And if you make some small modification and you run it, it should ideally only change the things you changed and not like go reprogram the universe. So the whole notion is that you hope you can make small controlled changes through this mechanism in a way that can be stepped and controlled. That's the idea behind this larger movement called infrastructure as code. So there's some tools that the world has developed, the IT world, nothing to do with television. And we're going to talk about each one: Ansible, Terraform, Kubernetes, CICD. Anybody know what CICD stands for? Okay, it's continuous development, yes. Which is sort of the summary of what we're talking about here: continuous integration and continuous deployment, I think sometimes people say. And then there's a related topic called the single source of truth, which is where do you store configuration information that everybody can point at and say, is this, how do I make the system match that, or how do I make that match the system, and which direction does truth go? So first I want to mention Ansible. So Ansible, nice big logo. There used to be a book about that. Ansible is primarily is an automation tool, but it also does some provisioning, where provisioning is configuring settings. So Ansible, everything it does is kind of organized around the idea of automating a process, meaning it's driven by, if I see this, I do this kind of logic. So Ansible's designed that you can build, change, revise infrastructure from a file, just like we said, that you can, Ansible's built around a thing called a playbook. So a playbook is a list of plays. The plays each have some actions. There's just, you got to have a vocabulary to describe things. But basically, what Ansible's used for all the time is spinning up and configuring virtual machines and instances. And so a lot of its built-in capabilities are built around that, around being able to spin up virtual machines, spin up instances of computing. But you could, in principle, do anything with Ansible. It's sort of open and flexible. One of the biggest uses of Ansible right now, other than turning up VMs, is anybody here turned up an Arista network in the last couple of years? So Arista has made huge use of Ansible as a configuration language where you can go in Ansible and say, I'm going to have these VLANs and here's the switches, and it goes kaboom, and it builds out the configuration for all those switches. It's really quite handy. And it's a good example of using Ansible to do a powerful thing. So Ansible, like I say, it's an automation tool that knows how to automate configuring, among other things. And, do you need to write all these plugins yourself? Well, hopefully not. And one of the great things about Ansible is there's a great big variety of, pre-built, what Ansible calls collections. A collection is a collection of plays that you could put in your playbook. So there's pre-built playbooks or collections from Arista and Cisco and all the usual suspects. And as a vendor, that's what our intent is also, to work on a playbook for your collection for our products, to say, okay, how can we put those in so that we can use Ansible to configure equipment. But very wide set of support in the wild. Obviously, it's all kind of there on GitHub. You can download it, which is good and bad, because that means you also have to check whether it works for you. So you might have also heard of a thing called Terraform. Terraform from HashiCorp. Who's HashiCorp? Don't dig too deep. Terraform is the other way around. It's a provisioning tool that does some automation. And remember, Ansible was an automation tool that does some provisioning. And it's key to understanding them, that what is their first focus and what is their maybe I do that too. So Terraform, its goal, again, was to build, change, and revise infrastructure by defining it in a file. That's what we all hope to do. But it uses completely different words. So it talks about providers and resources and infrastructure objects. And basically, the key thing in both these languages is to understand this concept of idempotency. And there's a word that was on the spelling test in 10th grade. Idempotency is the idea that if I run these instructions, I get a result. If I run them again, I get the same result every time. And particularly if I then run some different instructions, I get some other result. I don't like that result. I go back and run this version of the instructions again, and I get that old result again, reliably. Because that's what you want to do, right? You want to be able to roll forward to the new set of instructions, say, oh, that worked, great, or say, oh, that, and then you roll back and you get the old one to work properly. One way or the other, you have to get, if it doesn't achieve that, then you'll never use it again. So that idempotency is a big difference between Terraform and Ansible and how they achieve it. Terraform, they've built the whole design of the thing around ensuring that idempotency by making it super constrained in how you describe things. Whereas Ansible is a little more like, you should keep idempotency in mind as you write your collection and be very careful. It's advice, not rules. But there's always a downside too. There's a reasonable number of third-party plugins for Terraform, but not nearly as many as Ansible. Ansible seems to be where the tide of the industry really is on the IT side. It's certainly, certainly the one that we're looking at, and it's the one Arista bet on. It's the one Cisco bet on. So but that's the general sort of overview of both of them. Now, you might have heard of Kubernetes. Kubernetes is like a whole nother, funny word. So Kubernetes is, again, the idea that you build, change, revise the application state, in this case, by defining it in a file. That's like the whole theme here. But Kubernetes has its own entire vocabulary where they talk about objects and deploying, and it's built around the idea of a cluster of computing. It's very computing-centric. So if you're deploying an application into a Kubernetes cluster, Kubernetes is all about that. Some people have tried to use its control architecture to do other things, and the further afield you get, the more harder you're working against it to do those things. But it is something I hear people try. Oh, I'm going to use Kubernetes to do, like, program my car. It's like, really, why would you do that? Like, yes, you could, but just doesn't make any sense. So of those three, Ansible seems to be the one that's getting the momentum of the industry in terms of using it as an engine to configure and deploy stuff. Now, I want to go back to these two terms, immutability and idempotency, because they each have a really important meaning that you have to keep in mind and strive for. Immutability is a hard one, right? Because it says when you create something, it has some identifier that doesn't change. If any of you have worked with NMOS, so NMOS has all these GUIDs, and you think, oh, a GUID is an identity. Are GUIDs immutable? Well, they're meant to be. That's what the I in GUID stands for, is immutable, globally unique, immutable identifier or something. So if you, for example, spin up a virtual machine that does something, and maybe it has NMOS senders and receivers, those will have GUIDs. If you use the same instructions and spin up another virtual machine, will it have the same GUIDs or different GUIDs? Well, is it the same VM doing the same thing? Is it a copy of it doing a second thing? Like, you have to get this right, because I've seen this just be incredibly problematic, where people will say, oh, well, I spin it up and I assign a random ID and that's my ID. But the whole architecture of most control systems requires that these immutable identifiers be the same for the same thing time after time. So if I'm spinning up the first playout instance, it better have the same GUIDs every time. If I tear it down and spin it up again, it better have the same GUIDs if it's meant to be the same thing. So that immutability of identity and managing that, especially as you start spinning up virtual things, it's where the rubber meets the road. When is a virtual machine not really virtual? Well, when it's running and doing something you care about. And that's when it needs an identity that doesn't change. And the idempotency we talked about, it's when I run the configuration script, does it wind up with the same result no matter what state things were in before? If there's extra stuff, does it turn it off? If there's something missing, does it create it? That's the goal as you create these playbooks and plugins and collections, is to achieve idempotency. And if you can't achieve it, these systems don't work as well. So CICD is a process that we use internally in creating software, and large websites like YouTube or Facebook or something use this generally as part of their deployment mechanism, that developer makes a change, it winds up getting pulled into the build. Like in our case, we make products that run in a rack. So every day, developers make changes, they get pulled into the system, they get built, and then they get deployed into a test system that runs overnight. Test system runs automation scripts that say, hey, do all the features still work like they did yesterday? Did that change break everything? And then by about 10 o'clock the next morning, it pops out a result, and those changes either get committed into everybody else's build, or they get rejected and the developer has to go sort out their business. But this automation cycle of, did the feature work? Did the change work correctly? Somebody checked it. It goes off usually to a human to check that the specific thing that was supposed to be fixed really got fixed. Then it gets deployed into the release and tested as the release. This process, as product developers, we've used it for years. many like big websites and things use it as a mechanism. They deploy a change to the site to like a staging server, and they go check it and say, okay, does the staging server look right? Does everything work right? And then they say, yes, this is good, and then it gets deployed to the real system. But the automation of these deployments and the automation of the process of, make a change, check it, make it in the bigger system, check it again, that's what continuous integration and continuous deployment is about. The alternative is like when you build build a big waterworks project, and you dig out the whole canal, and then you make a million things, and then only at the end do you put water in it and see if it actually works. But in these systems, the idea is you make incremental changes, and at each point you check, did this do what I expected? Did this work? So that's continuous integration, continuous delivery, continuous deployment, and each of these charts I tried to put the, where did I get these pictures? I didn't make these things up. The IT industry has developed these concepts, and we all shamelessly use them or should use them. Now, another thing that comes up all the time as you start deploying particularly these 2110 systems, there's a million details. There's a million IP addresses and other stuff. Where's the source of truth? Where's the master list? And in every facility, it always winds up being a big spreadsheet, that somebody's got the copy of the spreadsheet that has everything in the system. And that's really unfulfilling and seems wrong, but every system seems to do it that way. What would be a better way? So some very large enterprises now are using tools to track this stuff. And there's two primary tools that are used. So one is Infoblox, which is expensive, has a million features. Did I mention it's expensive? But it works really well. And Infoblox has, ways to deal with switch configurations and IP address management, all kinds of nice stuff. And then for people who want to experiment and don't want to spend any money, there's Netbox. And Netbox is open source. You could build it. It's free. Works nicely. Doesn't have all the same capabilities as Infoblox, but it's a good way to get started at the concepts of how a single sort of database and way of using it can keep track of all your details, and then you build your scripts to pull or push data from Netbox. Now, this is where it gets funny, because you might think that the single source of truth is like you start out by putting the details there, and then everything should pull from there. And that's a model, but it's not the model most people use. Another model is you say, well, the single source of truth is really a place that truth collects. So if, say, a DHCP server assigns an address, that would get propagated up to the Netbox or Infoblox. And that seems to be more the model, that people use these systems not as a source of truth, like the name might imply, but more like a destination of truth, a collecting point for the state of the system. And honestly, I've seen deployments where people use it both ways, and that's really scary, because you have some data in it is trustworthy, some data in it is accurate, but not trustworthy, and some data in it is both, is actually correct and you can count on it. And there's no right answer. It's really very situational on specifics of your deployment. I wish I could just tell people, oh, just do this, it's awesome. But the reality is you have to think through how your workflow works. If you're adding a device or building a system or adding one incremental change to a system, how do you know what you're adding it to? And IP addresses are especially vexing, because there's DHCP, which is great. When you plug your laptop in a hotel, DHCP assigns you an address. You don't even think about it, right? It just works. And you would think in these television environments, we would use DHCP. You plug in stuff, it gets addresses, it's all awesome. But there's incredible resistance. Everybody seems to keep their own spreadsheet and want to have a spreadsheet of all their addresses. Well, nicely, DHCP integrates with these Infoblox and Netblocks and at least tells you what addresses it allocated. But even then, there's like resistance to using these tools. And I think it's just the old school broadcaster mentality of, I want to have a list, and it's my list, and I picked the address. I don't want the DHCP server picking an address. There's also always a fear that if you make this stuff too codependent, that, you know, lightning strikes outside, your transfer switch fails, the whole facility powers down. As it crawls back to life, suppose the DHCP server isn't up when things start coming up, and maybe it comes up later. Oh, you got a big disaster on your hands is what happens then, because nothing gets an address, and they come up and they start assigning random addresses, and all kinds of terrible stuff happens. So that's another reason why I don't see everybody just jumping into using DHCP for everything. Appealing as it is, there's also a downside. You know, think about an OB truck where powering up is like a daily event, right? DNS could be part of a solution. I know customers who talk about making entries in the domain name server for every flow in their system. You could do that. It's a lot of entries, and what's going to look at them? Now, you could also put entries in netbox or info blocks, and they're more like databases that things can access, whereas DNS is more like a, you know, yeah, you can type and look up DNS queries, but who does that? And then there's people who actually make integration suites of those things that all work together, and they're nice and neat. So tell me if this is the big turn.
This is the big turn.
Okay, so I'm not going to leave you any time. No, don't worry. And then Ansible knows how to do this stuff with these DDI tools. And likewise, you know, Ansible and some of the other tools, they know how to push things into info blocks, into net blocks. So why do we care? This is the meta question and the wrap-up. You know, if you think back to the analog days, I never worked on analog, but maybe some of you did. You expected every engineer in the plant to have a little green screwdriver and understand what's a resistor and what's a capacitor, and at least you didn't have to design the camera, but you had to know how to get it to be the right colors again. Okay, and you were expected. That was just part of being a television engineer, was understanding enough to do. Now, think about the modern equivalent, right? So if you're working in a, say, a TV station, you've got all these complicated file-based workflows that are getting ads in and getting content in from networks and putting it in a media database and playing it on the servers. And if that stuff breaks down, you're pretty much off the air pretty fast, right? How many people in a typical plant understand how to get that running again when it's not running? Hopefully at least one, right? On every shift. Well, that's kind of where we are now, is you say, well, in these software deployment, blah, 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 future things, it's the same idea. What knowledge do we expect a television engineer or somebody on staff to have about how to deploy changes, how to roll back changes, how to recover systems to known states? That's why these tools are important, is because they're enablers for doing that in a controlled, organized way, instead of having individual staff members go typing on the CLI of the switch trying to like debug or configure something. So that's all. Thank you all. And if you have questions, they need to be quick because I need to leave him some time.